Hi there, my name is Murray Oldfield. I'm a technology architect here at InterSystems. If you've been to any of the other sessions in this room, pretty much the technology architects seem to own this room. So what we do is we talk to vendors and customers and internal divisions as well about questions around architecture. So servers and storage, capacity planning, performance planning and performance reviews. And we work with vendors on things like platforms. So whether it's AIX with their, or IBM with their AIX, or Linux on Power, or VMware and Intel with vSAN or Nutanix. So we do benchmarks as well to prove cache. And what we usually use, because I live outside the US, where InterSystems sells their TrackCare product, which is a hospital HIS system, we use TrackCare as in fact the application for the benchmarking. So I have a lot of experience with capacity planning. I have a lot of experience talking to customers in the TrackCare vertical who are moving from physical to virtual. And so what I've seen over the last 4 or 5 years is as customers go through their technology refreshes, as they go through going off to buy their new hardware and in cycle with upgrading their TrackCare application, is they're taking the opportunity to move to virtual as well. So these are the things I'm going to talk about today. The experience I've had with the TrackCare customers predominantly, other customers as well. We use VMware internally within InterSystems a lot as well. So just a quick poll of the room. How many people here are using just VMware generally in their organizations now? So pretty much everybody. And how many people, so a tier 1 application is like your production database, your primary business critical systems. So how many people have got their tier 1 applications, their tier 1 cache or HealthShare or whatever on virtual? So about a fifth of the room. So the rest of you guys are here to see, can you do it, and perhaps what might be holding you back, and what the answers to that might be as well. So we're going to go through a checklist of things to think about, and I'm just going to talk about my experience, and I'm going to show you some examples of some stuff we've done as well. So what are the roadblocks? What's stopping the people in the room who haven't gone to virtual already? Well, the first thing that usually comes up when I sit down with a customer is they say, well, will InterSystems support us? In performance and capacity questions. Oh, we're going from something physical that we know how that works. We've been doing it for the last 30 years. We're going virtual now. We're not sure what's going to happen next. And other things like, is it going to be more expensive? Are we going to lose our availability? Is management going to be harder? We've got security issues and things like that. So is there anything on that list that is a concern to you about moving the tier 1 to VMware or to virtualization? Anything? Anybody got anything else on their mind that maybe we can talk about? Yeah? Oh, okay. Okay, so the question was, they've got their application servers, this is for the record, for the application servers on virtual, but not your primary database, and your concerns are about I/O and block storage and VMDKs and stuff. So there's a section in here where I talk about I/O, and I'll answer that question there. And I've got a bag of Caramello koala bears here to get rid of, so anybody who asks a question or answers a question, you have a koala bear. So chocolate, Caramello chocolate. They're a bit funny shape because my bag got hot in transit and they all got squashed. So first off, support. Yes. Maybe I should just get rid of this slide now. Yes, InterSystems support you on VMware. Yes, InterSystems support you on any virtualized application, on any hypervisor, including Linux LPARs on AIX and Hyper-V for your Windows. So InterSystems' position is we support operating systems. So if you go for our website and you look at supported platforms, what you're going to see is a list of Red Hat, AIX, SUSE, Windows, VMS, whatever. So we support the operating system. What you run it on, the platform, is up to you. So whether it's something like Nutanix or vSAN or just plain old VMware, or it really doesn't matter. Now, when I talk to RB Omo, who is the manager of InterSystems WRC, about, well, what happens if somebody rings up and they've got their application is running on VMware and they've got some performance issue, what do you do? And really what we do is we just treat it like it was on physical. When you ring up, tell them it's on VMware, because we need to know. But usually it's the same old issues, I/O, IOPS aren't being catered for, or you've got a CPU problem, or there's something going on somewhere. But we just march it on through as though it's anything else. And the other thing is, pretty much generally, it's never an issue anyway. It's very rare that the virtualization platform has anything to do with your performance problem. The platform itself. It might be the storage underneath that's got a problem, but not the platform. If it ever gets to the case that, yes, it is an issue with the hypervisor, then we'll just hold your hand and work with you to solve that as well. But it's never happened in the past, as far as I know. The full text, if you ever have to talk to your managers or your customers of what the exact wording is for our support is on that link there. The slides are available, I thought now, but certainly immediately after the conference, and the same with the audio as well. Sorry, the question is, what is the subject of the presentation itself? So this is moving your Tier 1 applications to VMware. So it's a platform. So the next question that comes up is performance and capacity. If you Google eat your own dog food, I don't think you'll like what you see, but InterSystems does deploy the TrackCare application pretty much 100% on VMware. Or even our biggest customers now, the default platform is VMware, default operating system is Red Hat, but SUSE is in there as well. So we use it day in, day out. We're deploying it all the time. We definitely recommend it. We have some very big installations using VMware, and more bigger ones coming down the line as they go through their technology refreshes. vSphere 6, which is the current version, these are the maximums. 128 CPUs, 4 terabytes of memory. Has anybody got a system bigger than that? No. Has anybody got a system, that needs more than 24 CPUs in the Intel world? Yeah, how big? How many? 80. So you're pushing the limits, but it's still possible. If you have a 4-socket server with 80 cores in it, you could virtualize it. Virtualization itself has a little bit of an overhead on the host, maybe a couple of percent, but if you're sort of within that couple of percent, you've probably got more things to worry about. The reason, why would you do that? Why would you, say, dedicate a whole physical host and still use VMware? The question's, or the answer is generally because it's part of VMware's part of your infrastructure anyway, and it's easier to manage. And now you're taking on board and getting for free the VMware manageability stuff. So things like the vMotion and the inbuilt high availability and the other management and security stuff that comes along with it. So that's what it may sound insane to have one VM on a host, but usually the host is part of a cluster anyway, and that's part of HA. Have you virtualized that database yet? You have. So you've got that 80 CPU system running on VMware already. Oh, there's a great reference for, yeah. And with TrackCare we find the same. We have some very large deployments in the pipeline which are basically the same sort of thing. There's nothing to be afraid of there. The other thing is, and because my job a lot of the time is capacity planning, VMware is great for me. If I'm talking to a customer and I say, well, look, you're going to need 10 CPUs and this much memory and this much storage, and then partway through the project something changes, or just before they go live or just after they've gone live, that doesn't matter. Oh, we need 2 more CPUs, we're really getting close to that 100%. Well, that's okay, we'll just add some more. Back in the day when we were using physical servers, if I had an 8 CPU system and I needed 10 cores, I'm going to the shops. I'm going to Dell and getting another server. So it's fantastic. It makes your job and my job a lot easier. And I'm not here to sell VMware, but it's being driven by the customers. Customers have already got VMware infrastructure and we're just putting TrackCare in there. Or quite often we're the wedge, we're the first VMware implementation for a site. So we're being used as the way to get it in the door for the hospital. But, a couple of other things around performance. When you vMotion, this idea of VMs can just move from one server to another in a cluster. Really your users aren't going to notice the difference. As long as your networks and things are set up correctly, it's just not an issue. This can happen automatically because VMware can do leveling and load balancing, or you can just do things manually if you're doing maintenance or you want to control that yourself. The one on the other side there, the CPU utilization, that system is there running at 100%. I forget how many cores, maybe 8 cores, and then we added another couple of cores and the utilization goes down because now we've got more CPU. And that's a cache system, and I did that at a benchmark just because I was curious to see what cache would do when suddenly another couple of CPUs fell out of the sky. And it just started using them. Cache is process-based anyway, so it's just another, processors just start using the CPU cores as they became available. There's some caveats around that. vSphere 6 will let you do that a lot easier than earlier versions. In earlier versions, if you set it up so that you could do that hot add, then you upset the NUMA, which is the architecture underneath. So I'll talk about that in a second. But certainly with vSphere 6, it's a lot easier. I'm not sure if hot add's supported for Windows yet. It is for Linux, I know. So this is our cookie cutter, out-of-the-box TrackCare architecture. But it's pretty much a generic architecture for most applications. We've got our tier 1 database, it's a bit bigger than the others, but it's sitting there on a pool of, 3 servers, 3 hosts in the cluster. Now, if you imagine they're, say, just a commodity 24-core server, so now we've got 96, 48, 96, is that the right number? Cores sitting there in our pool. So that tier 1 database could be sitting on any one of those hosts. And plus we have all the other things that come along with your application, like web servers and print servers and whatever other servers you need, plus non-production. So we actually mix production and non-production together for most customers. With all of that horsepower there, you've got a lot of resources, a lot of memory, a lot of CPU at your disposal, so we might as well use it. If you do that sort of thing, you do have to be a little bit intelligent about things like your storage, separating your storage out so that your production storage is separate from your non-production and things like that. But there's really no reason that, for most sites, that you can mix production and non-production. VMware has this idea of a cluster. So for them, a cluster is just a group of machines from 3 up to 64 servers in a cluster. And your application could be on any one. It can vMotion, so you can move it around if you wanted to. If you wanted to separate, say we're doing a big migration or an upgrade and you expect a lot of activity on one of those VMs, you could separate that from and make sure it's nowhere near your production machine, for example. So you can move stuff around on demand. And the HA is simply, if a server fails, the VMs running on that server will start on another server. So your cache application will start up and recover, just like it normally would if the server power had gone off. If you get a blue screen of death, then that VM will just start up again. That operating system will just start up again on the same place. So that HA is just built in. So you've got some downtime with that. The time it takes to restart the operating system and cache and do whatever recovery cache has to do in the journal recovery. But it's out of the box, batteries are included, pretty simple. Usually we have asynchronous mirroring off to the DR side as well, and DR is just simply still on VMware but probably not a cluster, maybe a single server with 100% performance but no extra HA, just the extra box itself. Does this look sort of familiar to the people who've got VMware already? It's pretty standard stuff. The shared storage at the bottom, that's the typical deployment at the moment. Obviously you need shared storage because the VM could be anywhere, so you'd be able to connect to the disks. But what we're seeing now is hyperconverged, so the vSAN, the Nutanix, that type of thing. There's some sessions these few days on hyperconverged infrastructure. So that's where what's happening is the shared storage is moving, it's not external, it's actually moving into the boxes themselves. So it'll be SSDs and spinning disks, or in fact just all SSDs. And what those technologies do is they handle the HA at the storage level by every time you do a write, it gets written out to 2 or 3 other places depending on your requirement. So we're benchmarking vSAN at the moment with VMware and Intel, and I'm starting a Nutanix benchmark next week. So as that information comes out, what I think I'll do is probably, we publish that anyway, but I'll be putting it on the developer community, like the white papers that come out at the end, so you guys can read them, see what the results were, and see if it's right for your organisations as well. This is actually the default we give most customers, except for the very smallest ones. We call it HA Plus because what we've done is add to the VMware, we've added mirroring. So who here is aware of cache mirroring? Pretty much everybody. Who here is actually using cache mirroring? Nobody. Oh yeah, a couple. So it's been around for about 5 years, cache mirroring. And for track care, it's, like I said, the default. And I think people know how mirroring works. We're basically just replicating the data using journals from one mirror to the other. And I think there may be even mirroring presentations if you want to know more. Your storage is separate down the bottom because we're replicating the storage through journals. We're not doing block level replication because, for a start, we want to keep it simple. And for second, block level replication, if you get data corruption, and I've heard of this happening at sites, in fact just recently, corruption of your database on one array, and block level replication will happily replicate those corrupted blocks across to the other array. So there's a few nods, obviously it's happened to other people. In the VMware world, in your shared storage, maybe it's too expensive to have them in separate arrays, but certainly have them in separate shelves or separate disk groups, just to give you that isolation. What it adds at the HA level at the top, though, is that imagine mirror 1 there on the left, this host had a failure, or the operating system had a failure, or another extra thing is, imagine your application had a failure and cache went down. Well, now the other mirror knows about that, and it will start up immediately. So you've got a couple of seconds downtime. You don't have that full recovery of operating system, cache, all of that. That instance is running, it's ready to go. So the users are going to end up logging on to mirror 2. Whatever recovery is needed over here on the VMware side is going to happen. If that VM had to, that host went away and the VM started off on that middle server, that can come up, but it'll come up and cache will know it'll come up as a backup because we've got a primary already. So it's sitting there waiting now, and you've got your full HA back again very quickly. The key here is that we've got a very fast failover. You can vMotion it around and do all of those sort of things, just like you normally would as well. So there's a couple of rules. So VMware has affinity rules or anti-affinity rules. So imagine like, a magnet, how you put magnets together. If you put them the right way, they sort of push each other apart. So you have affinity rules for your mirrors. You never want them on the same server, obviously, because if the server goes away, your database does. The extra cost is you've got a whole other VM running, and you have to allocate the resources for it because you don't know when it's going to come up, and the cost is also the storage. But if you're a very large hospital 24/7, it's probably quite a small cost. Okay, so I go through this a lot with customers. How do we move? Well, the first thing is we just baseline. Baseline means collect all your performance stat from the current physical system. I've had a session yesterday, I've got another one tomorrow on capacity planning. I talk about the things you should collect. But what you need to do is you need to know what your CPU requirements are, what your memory requirements are, and what your I/O requirements are, and then we can take that and map them to physical, from physical to virtual. And of course that's actually really easy because it's the same. If you needed 10 cores on a physical server, you need 10 cores on a virtual server in your VM. What I find when customers are moving from, say an old DL380 with 12 cores to a new commodity Dell R730 with 24 cores is, we've still got, even if we had a whole VM with that 12 cores, we've still got 12 cores left for other stuff. So we're generally moving on the old technology to something with a lot more capacity. And when you put them in a bunch of 3 or 4 or something like that, then you've got an awful lot of room. But the basic rule applies. 6 CPUs, 6 CPUs, same. Your I/O requirements aren't going to change. You may get a little bit of a performance bump because you're going to new technology. And in the capacity planning section, I talk about that a little bit, about how you might plan from going from old CPUs to new ones and how you get the uplift there. We always test the systems anyway. We do a burn-in and do some test analysis like I/O tests and things before we move them across. So I'm going to talk about some specific sort of what I call the hardware food groups. CPU, memory, and I/O. You want to get your food groups, you want to have a balanced diet, you want to get these in balance, and you want to think about a few things. So, as I said, we size CPU core to core, and a very important thing is, so some discussions I have with customers, for your production systems, for your tier 1 systems, don't oversubscribe. And what I'm talking about there is, imagine you've got a server which has got 24 cores in it. VMware will let you create VMs on there you could put 56 cores worth of VMs on there if you want. And that's called oversubscription. And the idea is that they're all not peaking at the same time. So that melded VMware megahertz that's available is going to be evened out by the hypervisor, and you can get all of these things running and getting 100% out of that host now. And you've got this consolidation. You've got things all squished on there. And you've been able to get rid of all these physical servers, and that's one of the selling points of VM. But for production servers, don't do that. Certainly not to start with. I always tell people, provision your production servers core for core. If I've got 24 cores, put 24 cores worth of production VMs on there. Then monitor. After you've gone live, after you've got real users on the system, if you're running serialized operations or those type of things, it can tell you, okay, well, you can actually shrink these VMs. These ones are over-provisioned. You can actually get some more consolidation. For non-production systems, as a rule of thumb, I just use a 2-to-1. Your test and dev servers are quite often just spinning, doing nothing anyway. But my number one rule is 1-to-1 for production. The other conversation I quite often have with customers is around hyper-threading. So hyper-threading in the VMware world is, and in the real world as well, is if you have a CPU core, 24 CPU cores, and you've got 24 things in your run queue, they're going to use all 24 cores. And then if you get some more stuff, then it's going to start using the threads, and it's going to start piling up on them. The thing is that you've still only got one CPU core. It's doing a lot more work now, but the uplift is only going to be in the order of 20 to 30% at most. And we've borne that out with benchmarks with cache as well. So the conversation I have around that is that when I tell customers we've got 24 cores, let's put 24 cores worth of production on, they go, no, we've got hyper-threading, we can put 48 on. The answer is no, you can't. And that's been borne out by experience. The point about wide and flat, I bring that up because it's interesting. When you create a VM, you're creating a machine on the VMware, and you can tell VMware what that machine looks like. It's got this much disk, this networks, and this is what the CPU looks like. So if you imagine a physical machine has 2 sockets, and it's got 12 cores on each socket, that's what it looks like. But you can tell VMware anything. You can say, I've got a machine that's got 24 sockets with 1 core on each one. And in fact, that's how VMware likes you to specify it. And that helps with the underlying NUMA and your memory management and your processing and the scheduler. Okay. But for some applications, that presents a licensing issue because they license per socket. It's not an issue for cache, but if you're running third-party apps on your VMware infrastructure and it licenses per socket, and the software sees that you're running that many sockets, you might have a licensing issue. So it's just something you have to take care of. When you license like Red Hat running on VMware, you license per physical socket. So 2 sockets are on the server, not however many you say in the VM. No. Well, only if you've got a particularly large installation and you're going over those limits, or you've got a standalone system that just maybe just does nothing else. But really, like I said, for the last 3 or 4 years for track care, this is eating our own dog food. We recommend customers are virtualized. We've got data centers around the world; they're all virtualized. There probably is use cases, but not for the databases I see. Not just cache, not just track care, but any. And this is, I guess, what I'm talking about today. I'm trying to sort of not dispel myths, because I don't think they're myths. I'm just sort of trying to set the scene for you so you can go away and say, yeah, we can do this with cache. It's not a problem. So NUMA it's been around since last century. When I worked at Data General and Sequent, back in the 90s we had it. But since the mid-2000s, all the Intel servers come out with this. What NUMA is, who knows what NUMA is? Oh, that's good. I can tell a story now. So what NUMA is, imagine you've got a 2-socket server and you've got a bunch of 24 processors, so 12 and 12. The way it sets up is like in that picture. These processors have some local memory, and these processors have some local memory. So if I have a cache process, my cache.exe or cache process running on C2 there, VMware will work hard to make any memory it accesses nice and close on that memory that's attached to that processor. If it has to go across that QPI bus down to get some memory here, then there's a hop there, and it's going to cost something. It's going to cost nanoseconds, but it's going to cost a little increment of time. And if you do that a lot, it adds up. So the reason I set that picture in your mind is because what we want customers to do, if they can, is you size your VMs so they fit in the NUMA node if it makes sense. Or if you want to flip that on its head, you buy your hosts so your VMs will fit in the NUMA node. Now, the same thing goes for memory. If I've got 64 gigabytes of memory on each of those processors, that means a nice comfortable size for that VM would be that much memory or less for my cache instance, and that many cores or less for my cache instance. And it will fit in the NUMA node, and VMware will work hard to keep that happening. If you can't, it's not the end of the world. It's not a big deal. If you've got one of these, 4-socket boxes, they have a crossbar bus in the middle, and it's still cheaper to get memory from far away on the processor than it is to get it from disk or somewhere else. So don't get too hung up on it, but if you can plan your systems that way, you're going to get a little bit of an advantage. And remember, cache is an in-memory database. The more things we can do with memory, the better. There is one Intel architecture that doesn't have that cross in the middle. It just has a ring. So it is possible you get 2 hops, and we generally recommend people don't use that for VMware. The key thing out of this is probably the second point here. Try and right-size your VMwares. I'm going to show you an example in a minute that I got this morning from a customer where they've over-provisioned their VMware. But as a rule, if I've got a 24-socket box and I know that my VM only needs 8 cores, size it at 8 cores. Don't just say, well, I'll give it 24 and VMware can go and sort it out and I'll have lots of headroom and I'll be just bumping along at 10%. It's not a good idea for a couple of reasons. One is you're going to incur a little bit of performance overhead. VMware is going to try and schedule in parallel those cores all the time, so it's going to be trying to fit those in, and you're going to have problems with that as well. So the rule of thumb here is make sure you're right size. If you've installed your system and you're finding that you're not using all the CPU resources, you're just using like 20%, the next time you have an opportunity, try and size your system down, because it's going to be better for that application and any other applications, and you're going to get your consolidation ratios up as well. So thinking about memory, it's, as I said about the NUMA, the other thing is, like, cache is an in-memory database. Where don't I want my memory to be? Any ideas? Sort of a woolly question. I don't want my memory on disk. I don't want it paged out. So within VMware, what you can do when you create a VM, you can reserve CPU and you can reserve memory, which essentially says it's for me and no one else. We generally recommend people leave the CPU alone, let VMware sort all that out. But you can reserve memory. Now, that means that if I reserve 24 gigabytes of memory, because that's the size of my VM, no other VM can use it. Now, VMware has a lot of really neat technology like transparent page sharing. So if you're running VDI with lots and lots of workstations, essentially you only get one copy of the operating system and they all share it. But that's not going to be happening with your application or the cache shared memory anyway. So if you reserve that memory, you're stopping anybody else taking it. If that server gets under pressure for some reason, a VM's been migrated there that's doing something that it shouldn't be, you're still reserving that memory for cache. At the minimum, allocate your shared memory, your global buffers, routine buffers, GM heap, make it at least that big and maybe 10% bigger. Ideally, just make it the whole size of the VM. This is going to guarantee your memory, and it's going to guarantee your performance. There's another sort of side effect here is that swap space. So as we step up into the larger VMs, if we have a 96 gigabyte memory footprint for a VM, and that's actually quite common for the track here, you want nice big global buffers, then that 96 gigabytes is going to also get allocated as swap space on your storage. So that's probably expensive SSDs. So allocated memory minus reserved memory equals the swap size. So if you reserve all your memory, your swap file is going to be 0. So you've just saved a boatload of storage on your expensive SSDs. Here's a consideration though when you're doing that. A VM won't start when you've got reserved memory on a machine, on another host if the memory is not available. So you're playing Tetris a bit here. So here's problem. That guy gets moved over. Oops, I can't move him now. So there's ways around it. I'm putting it up here. I'm not going to tell you like step by step what you have to do, but essentially what you're going to be doing is setting shares, which is like priority. You're going to be sizing your system so that you're aware of this problem and you've got the capacity to be able to do this. It's just something you've got to think about once you reserve that big chunk of memory. It's not like it's a simple problem to solve. It's just something you've really got to put in your mind. At the worst case, what you can do is you can actually have like an N+1 architecture where you have a whole host that is free. It doesn't actually have VMs running on it unless another host disappears. Generally, people don't have to do that, though. You can usually work out your capacity in better ways. In my capacity planning section, I talk a little bit about this as well. And on the community of the developers, the developers community, I've been writing blog posts on performance. So on Friday, I posted one all about memory, how to size global buffers, routine buffers, GM heap, and so on. And I talk a little bit about this as well. Who here uses the developer community? Who's been on it yet? 1, 2, 3. Come up and see me afterwards, I'll give you a koala bear. You really should get on there. So I'm writing in the data platforms blog. I'm writing pretty much every other week a blog about these performance subjects. I'm sort of hinting at VMware at the moment. I'm trying to get through some other stuff first. But I'm going to start trying to do best practice for VMware and cache probably in the next month or two. So just go back there. If you've got questions, it's a great way for you to ask me questions as well, or just the general community. Your question about should I use RDMs or VMFS or whatever, the community would be a great place. Now, I'll answer you, but other people out in the real world will as well. So I definitely go there. It's a great resource, and we're getting a real bank of information. The picture in a summary is if you have a CPU, on the current CPUs they have 4 channels, and when you put your memory sticks in, your RDIMMs, if you put them in 1, 2, 3, 4, then you're going to get the maximum performance. If you put an unbalanced memory configuration, 1, 2, 3, 4, 5, 6, it's actually going to drop the speed of the memory. The memory speed will drop. Then the cache is in a memory database, slower memory, slower application. If you populate all 3 of those regions, it'll slow down as well. So why is this important? Well, I can buy 16 gig RDIMMs, I can buy 32, 64s. So just think about how you populate it. If I've seen, in fact, a customer order exactly that picture from Dell, and they delivered it. So it's a non-optimal configuration, and Dell just goes, well, that's what you wanted to buy, I'm going to send it to you, then I can check it. It's just something to put in mind. That link in the top is a guy, a VMware blogger, a VM blogger, I think, VMware blogger, who talks about this in a lot more detail. It's a very good blog if you want to go and look at this. Yes, in the situation where you want to avoid that. So if you've decided you need that much memory, then it would be better for you to buy 4 bigger ones and have a bit more capacity than you planned. So there's usually sort of natural breakpoints, like 64 gigs, 128, 256, 512. So as a rule, when I'm doing my capacity planning for the host, I just round up to whatever the next of those breakpoints is, because I know I'm going to get a balanced memory. Yep. So 128 would be just 32, 32, 32, 32. So that's how you work it out, just to get 4. So I want 4, or at worst 8. Don't go above 8, because then things will start to slow down. So there's 2 regions there. Once you go to the next region, it'll lower the clock speed of the memory. So yeah, just round it up by 4s, as long as they're balanced. You're getting, if they're not, it's not like the system won't work, but you're not getting the most out of it. And with cache, it's always better to have more memory. Memory's good. So I/O. I'll talk more about this on the developer community, but in summary, think about your real world. If I'm separating my journals from my data, my random access from my serial backup access, you do the same. You use disk groups, use whatever on the share. Keep your production, non-production separate. RDMs versus VMFS. VMFS is the native file system of VMware. It's the one they do all the development in. It's one where all the advances are. RDM is another one which is a direct access file system. There's some very specific use cases. One is Microsoft clusters. They need a shared quorum disk, and I think even that might go away. And the other is, I think Oracle has some special requirement for that. Cache, no, go with VMFS. For your block storage, what you want is you want your I/O capacity. So talk to your vendor. You can use NFS if your I/O requirements fit in the NFS capabilities. In the capacity planning session, I talk about sizing for IOPS and size and how you should think about cache and those type of things. But to answer your question, if I haven't answered it properly, I'm sort of running out of time. So if I haven't answered it properly, just come up and ask me afterwards again. But really, the rule of thumb is VMFS. If you're going with someone like Nutanix or vSAN, some of this stuff is being tipped on its head, and they're taking care of the high availability by making multiple copies. But the short answer is VMFS. For storage, for network I/O, the main one here is when you create your machine, you can say what sort of NIC cards you have. The default is an Intel E1000, but what you really want is a VMX NAT3. It's faster, it uses less memory. Red Hat and SUSE have drivers for it out of the box, so we use it all the time. It just works better. It's going to give you higher throughput as well. The E1000 will only give you a gigabit. And the other thing is, take the opportunity now when you're refreshing infrastructure to make sure your switches and everything else supports jumbo frames. Jumbo frames are just bigger frames with more data. If you're doing things, especially on your vMotion network, vMotion really likes jumbo frames, bigger TCP/IP frames, just to move more data at once instead of lots of little bits. So, yes, we do use this. Here's a site in India, as it happens. They've got 12 CPUs. They've got really high transaction rate. The global references is something of around 2 million. The CPU's bumping along. Everything's working fine. I put that picture in the presentation because I was going to talk about it. But this is one I got this morning from a customer. I was just doing a quick health check on them. So they're very similar. They're actually a later model processor. Still a big system, nice big fat global buffers, running Red Hat. The glow refs at about 1.8 million. But see the CPU graph. See CPU is just barely reaching 40, and this is a busy day of the week for them. So what I'm going to ask them to do is keep these stats going, right through their business cycle. And then what do you think I'm going to say at the end of the business cycle if everything still looks the same as this? Any ideas? Yeah, just reduce the number. You don't need it. You can get some more consolidation. You can probably put some more VMs on there. Yeah, over time, they want to do their capacity planning and planning. In 2 years, they might have a lot more patience or something. But a takeaway from this is make sure you right size your VMs. You're going to get a lot of advantages. It's not going to be difficult. Last thing I'm going to talk about is backups. VMware has a concept called a snapshot. So if I want to snapshot my system at a point in time, right now, I can just go and press a button and snapshot it. And what that does is VMware will, my data disk will be set to read only, and a little and a delta file will, or a disk in VMware is just a file. So that'll be set to read only, and a delta file will be created, and any subsequent changes, any updates you do in your cache application will be written to that delta file now. And that delta file will just keep growing with all the updates. And if I need to read some data, I'm going to read it out of the delta, look for it in the delta file, can't find it, I'll go and get it out of the other file. And I can daisy chain those. I can do another snapshot, another snapshot. Now you might do that if you're doing a patch or something, so for a specific reason. So you can roll back to a point in time. That's fine. We generally don't recommend people do it anyway, but the drawback of that is they can grow and grow and grow, and the system will slow down and slow down and slow down, and that file can actually grow to the size of your database if you do nothing with it. When you merge it back in, it's possible that the system could have a slowdown and a pause as well. So the mantra here is snapshots aren't backups. Snapshots are snapshots. Backups are something else. Most backup technology uses the snapshot technology from VMware to do its backups though, because how does a backup work? So VDP or Veeam or any of those other third-party products, how they do a backup is they do a snapshot and then they start backing up that read-only file. And then when the backup finishes, they delete or quiesce the snapshot, the changes get merged back in and everything carries on normally. So it manages that cycle. For your cache applications, you can use our freeze and thaw scripts to do all the normal things you'd do for an external backup. So if you're using Veeam or VDP or one of those third-party applications, look at the cache documentation, look at what you do for external snapshots. I'll probably write a post on the community in the future. These applications will have a place where you can put a shell script or a batch script to be called to do the freeze and thaw. And then it'll just slot in the normal scheme of things. I'll leave this homework for you because we've run out of time. But it's just a warning. The other is, no, I'll just leave it there. So with that, I found out how to do the evaluations of the presentation. Go to the agenda item, go to the bottom, and you can rate this presentation. And if you can do that, because we do want to know, are we on the right track? Should we be doing the same thing next year? And we really value the feedback. If you've got more questions, I'm more than happy to talk to you now, or if you just see me around.